So for my project, I have Newton's law of universal gravity. I'm introducing my scientist that I picked, Robert Andrews Millikan, born in 1868 and died in 1953. Life facts: Millikan was a American physicist born in Illinois, and he went to Oberlin College and for the University of Chicago, and later became a professor. And his research, he was famous for doing the oil drop experiment. He measured electric charge of single electrons. He also worked a photo effect studying how light particles can act. So, and basic definitions that I have is the mole, which is a way to count tiny particles like atoms or molecules. One mole has about 6.022 times 10 to the 23rd particles. I also have electron charge, the amount of electric charge in one electron measured by Millikan. Right. For my next slide, I have related fields. For my related field, I chose engineering, specifically aerospace engineering. And why I picked this is because it explains how Newton's law of universal gravitation is used in engineering to design satellites, rockets, and space missions. Engineers can calculate how gravity in motion affects the spacecraft and planets to plan orbit. For relevant scientist, I picked Robert Andrew Millikan, born in 1868 and died in 1953. I guess I already talked about him in my introduction, but he was born in Illinois, USA. He was born on March 22nd, 1868, and he died December 19 of 1953 in San Marino, California, USA. He grew up in a small town. He married Greta Blankert in 1902 and had 3 sons. Educational facts: he studied in Oberlin College, Ohio, where he became interested in physics. He earned a PhD in physics, Columbia University in 1895. Later studied in Europe, learning from famous scientists in German. And his research topics: he was famous for doing the oil drop experiment in 1909. He measured the change of electrons. He measured the charge of a single electron. Worked on the photoelectric effect, confirming Einstein's theory. He contributed to measuring Avogadro's number using his experiments. He also won a Nobel Peace Prize in 1923 for measuring the charge of electrons. And yeah, that's it for my project. Thanks for watching.
So my group topic was Newton's law on universal gravitation. Some basic facts and definitions for Newton's law on universal gravitation are: Newton expanded on the mathematical formula originated by Kepler. Force is a push or pull that changes an object's motion or shape. Gravity is a force that attracts objects with mass towards each other. And acceleration is the rate at which an object's velocity changes in speed or direction. The related field I chose was astronomy. Astronomy uses gravity to predict celestial events like eclipses and comet paths. Astronomy builds on Kepler's laws, which was proven by Newton. Astronomy studies stars, planets, and cosmic origins, and astronomers use telescopes and probes to explore deep space. The relevant scientist I chose was Henry Cavendish. He was born in 1731 in Nice, France, and he died in 1810 in London. He studied at Cambridge, but he did not receive a degree. He's famous for his torsion balance experiment in 1798. He was the first to measure gravitational attraction between masses. He also calculated Earth's density and paved way for gravitational constant. He also researched gravitational force and the Cavendish experiment.
How you doing? My name is Robert Red. I'm in the group doing Newton's law of universal gravitation, and these are my 4 group members. My introduction, done by Robert Red. It's about Isaac Newton in 1687. Explained both terrestrial gravity and the motions of planets and moons. The universal force of action acting between all objects with mass is always attractive and works within a line joining the centers of 2 masses. Newton's universal law of gravitation states that every mass attracts every other mass in the universe with a force directly proportional to the product of their masses and inversely proportional to the square of distance between the centers. And here's the formula for the universal gravitation. And another thing about Newton's law, every particle in the universe attracts every other particle with a force. This force is proportional to the product of their masses, inversely proportional to the square of the distance between them. Related fields, I chose classical mechanics using Newton's law of motion of an object based on the forces acted upon them. Incorporates Newton's law treating gravity as an inverse square law of force between massive objects. Newton's law made it possible for classical mechanics to become a coherent system that could describe both familiar motions and astronomical events using the same principle. And this is a picture I chose that kind of showed the Earth with the moon and Newton's third law, and just showing like how everything works in motion wise. And for my relevant scientists, I chose Sir Isaac Newton. He was born January 4th, 1643, died March 31st of 1727. He studied at Trinity College, 1661 through 1665, and he went to high school at King's High School 1655 through 1660. One of his inventions, Newton's method and a reflecting telescope. Isaac Newton is known for formulating the three laws of motion and the law of universal gravitation, which invented calculus. And this is a picture of Isaac Newton. And I hope you enjoyed my presentation. Thank you.
For my introduction, well, my name is Alicia Morris. For my introduction, I do have scientist Pierre Bouguer. For the life facts, Pierre was a French mathematician and geophysicist known for applying Newton's law of universal gravitation to study Earth's density. As for the research, Pierre is known for developing the Bouguer correction, which is a method still used in geophysics to remove the effects of elevation and terrain when studying gravity. Pierre's research showed that gravity changes depending on the altitude and mass beneath Earth's surface. For the basic definitions on this side, I do have listed geophysics, which is the branch of science that studies Earth's physical properties, such as gravity, magnetism, and internal composition, using physics, mathematics. I also have gravitational anomaly, which is a small difference in Earth's gravitational field caused by variations in the density of rocks or underground materials. These anomalies help geophysics discover natural resources and study tectonic movement. For my next slide, of course, I have my related fields, which is geophysics, like I mentioned previously. When it comes to geophysics, Newton's law of universal gravitation is used in geophysics to study Earth's shape, mass, and internal structure. Many scientists measure small changes in gravity to map underground features like mountains, valleys, and mineral deposits. This helps predict natural events such as earthquakes and volcanic activities, even things such as tides, ocean movement, and the balance of Earth's crust. For my relevant scientists, I do have Mr. Pierre Bouguer, mentioned earlier. Life facts I have here, he did work as a mathematician, physicist, and hydrographer. He was also known as one of the founders of geophysics for applying Newton's law of universal gravitation to study Earth. Not sure you can still see it. As for the research topics, I have that Pierre measured variations in Earth's gravitational field in the Andes Mountains. He also helped determine that Earth is not a perfect sphere, but slightly flattened at the poles.